Hello students, this is Dilip Udhani, Assistant Professor at LG Institute of Engineering and Technology. Today I will teach you ordinary differential equations of higher order. So first of all, we will discuss how to find out the solution of the differential equation of the form function of dy equals to x. That is method to find general solution of non-homogeneous equation function of dy equals to x, and the solution of this type of differential equation is given by y equals to cf plus pi. Okay, and cf, that is called complementary function, and pi is particular integral. Okay, we may write CF as YC and PI as YP. So the general solution of the differential equation of this form, function of dy equals to x, that is y equals to yc plus yp. Okay, and if you will be given the form like function of dy equals to 0, so that is called higher order homogeneous differential equation, and its solution will be given by y equals to cf only. Now in this lecture we will discuss how to find cf. Okay, so to find cf we have different cases. So to find cf, so just what we will do, we will equate function of d to 0, right? So if you have been given the differential equation of the form function of dy equals to 0, so to find cf, what we will do, we will replace function of d to 0, and then after we will factorize function of d, and then after we will equate all factors to 0, and from that we will be having different values of d. And if you will replace d by m, so you will be having values of m. So based on values of m, we will write down cf, and we have in different cases to find cf. So we will see first case number 1. So what is that? Case number 1 is if we will get the values of d or m, that is real and distinct roots, right? So you have to write down in this manner that if m1, m2 up to mn are the roots of auxiliary equation function of d equals to 0, then cf yc, that will be c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x plus dash 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 plus cn e raised to mnx. Okay, for example, if the roots are say 2, 3 and 5, then what will be the CF in this case? So CF, that will be C1 e raised to 2x plus C2 e raised to 3x plus C3 e raised to 5x. Okay, if I will give you one example related to this topic, consider the problem like this, that is d square minus 1y equals to 0. So in this problem, function of d is d square minus 1. So what we will do, we will equate d square minus 1 to 0, right? And then after we have to factorize. So applying the formula of a square minus b square. So we will be having a minus b, a plus b. So here the value of a is 1. So according to this formula, we will be having two factors. One is d minus 1 and other is d plus 1. Now we have to equate these two factors to 0. So we have value of d equals to 1 and value of d equals to minus 1. Okay. So according to case number 1, its CF will be C1 e raised to 1x plus C2 e raised to minus 1x. Okay. Now we will see case number 2, real and equal roots. Real and equal roots. If m1 equals to m2 equals to up to equals to mn are the roots of the auxiliary equation function of d equals to 0, then CF yc, that will be c1 plus c2x plus up to cn x raised to n minus 1 multiplied by e raised to m1x. Okay, if say roots are 2 2 2, right? So according to case number 2, what will be CF? That will be C1 plus C2x plus C3x square multiplied by e raised to 2x. Or you can write down in this way also. For this 2, you will be having e raised to 2x. For next this 2, you have to multiply e raised to 2x by x. So it will become x e raised to 2x. For next 2, you have to multiply e raised to 2x by x square. So it will become x square e raised to 2x. Okay. And then after you have to write down its linear combination. It means you have to multiply all the three functions by c1, c2 and c3, and then after you have to add the result. So it will become c1 e raised to 2x plus c2x e raised to 2x plus c3 x square e raised to 2x. You can remember in this way also, right? Now consider one example related to case 2. Say you have been given d minus 1 the whole square y equals to 0. Now you have to solve this equation. So we will find out its CF. To find out CF, we will equate function of d to 0. Here the function of d is d minus 1 the whole square, and that is equals to 0. So the factor d minus 1 is repeated 2 times. So we have d minus 1 equals to 0, d minus 1 equals to 0. So value of d is 1 and value of d again it is 1. So 1 is repeated 2 times. So its CF will be c1 e raised to 1x and c2 e raised to 1x into x. Then after its linear combination, so CF is c1 e raised to 1x plus c2 into x into e raised to 1x. Okay. Now we will see case number 3. See if the roots are complex roots. So one root is m1 equals to alpha plus I beta and other root m2 equals to alpha minus I beta, right? These are the roots of the auxiliary equation function of d equals to 0. So in this case, we will write down CF as e raised to alpha x cosine of beta x e raised to alpha x sine beta x. Then after this linear combination and taking e raised to alpha x common. So it will become e raised to alpha x into bracket c1 cosine of beta x plus c2 sine beta x in this way. Say the roots are 2 plus minus 3i or 2 plus 3i comma 2 minus 3i. So here the real part is 2, right? So it will become e raised to 2x and imaginary part is 3. So e raised to 2x cosine of 3x. Then after e raised to 2x sine 3x, and then after its linear combination. So required CF will be c1 e raised to 2x cosine 3x plus c2 e raised to 2x sine 3x, and then after you have to take e raised to 2x common. Okay, now consider one example, d square plus 1y equals to 0. To find out its solution we have to find out CF only, so we will equate d square plus 1 to 0. So if d square plus 1 equals to 0, so we have d square equals to minus 1, and minus 1, that is nothing but I square. So d square equals to I square, so d equals to plus minus 1 I. So the real part alpha is 0 and the imaginary part beta is 1. So in this case the CF will be C1 e raised to 0x cos 1x plus C2 e raised to 0x sin 1x, and e raised to 0x, that is 1. So the CF, that will be C1 cos x plus C2 sin x. Okay. Now we will discuss last case, that is case number 4, that is repeated complex roots. If alpha plus minus I beta, alpha plus minus I beta, these are the roots of the auxiliary equation function of d equals to 0, right? So here complex roots are repeated. So in this case, what will be the CF? So CF will be, you have to write down C1 plus C2x, okay, multiplied by cosine of beta x plus C3 plus C4x and multiplied by sine beta x, and in common we have e raised to alpha x. For example, if say these are two repeated complex roots, that is 3 plus minus 4i and 3 plus minus 4i. So here it will become e raised to 3x for real part. Then after c1 plus c2x, imaginary part is 4, so it will become cosine of 4x plus c3 plus c4x, and then after sine of 4x. Okay, so today we have discussed how to find out CF in 4 different cases. Okay, and thank you for watching this video.